CAP theorem is also known as Brewer's theorem. C stands for consistency, A stands for availability, and P stands for partition tolerance. So what CAP theorem says? CAP theorem says between these three means between consistency, availability, and partition tolerance, a distributed systems can have only two. That means a distributed system can be either consistent and available, or consistent and partition tolerant, or available and partition tolerant. In distributed system, all of these three, consistency, availability, and partition tolerant together, is not possible. So this is pretty much about theoretical definition. What is CAP theorem or Brewer's theorem? Let's understand this consistency, availability, partition tolerance, and CAP theorem in a very simple um, with a very simple example. So Ujjwal in my town has a grocery store, and everything for him was working fine. There was no issue, and his sale is good. Suddenly, he thought of going online, looking around apps, Swiggy and Zomato. He thought, I will also go online. So he hasn't done any fancy things. He hasn't developed any app or any software. What he has done is he just distribute his phone number to whole town. So usual grocery store started getting online orders, and how the things is working for him is customer make a call to Ujjwal grocery store and place his order. Ujjwal grocery store to place his order. So, for example, customer one place order one, customer two place order two. So, if you see right now, what is the requirement of Ujjwal? Ujjwal just need a phone number and a copy to note down the order. And because of Ujjwal behavior and the way he delivers the order, he started getting hundreds of order. His traffic increased and he started getting hundreds of order. So here the problem starts. And the problem is customer has to wait on phone call, um, and sometimes the customer hang up because of waiting on phone calls. He just fed up and he hang up. And one day what happened is Ujjwal get sick. Ujjwal gets sick. And due to that, he lost whole day business. So now you are realizing, right? What is the problem Ujjwal is facing? Ujjwal is not available. Right? So this is called the problem of availability. This is called availability problem. So to fix this availability problem, even in real world, to fix this availability problem, what you have to do is you have to scale up. So in real world, you add servers. Over here, Ujjwal asked his wife Neha, to join his business. And what he has done is he just get extension of that number and give it to Neha. So now customers calls on the same phone number. Phone number is same. For example, phone number is 11223344. Phone number is same. So customer calls on the same phone number. There is a router who routes the customer call to either who is available. If Ramesh is, if Ujjwal is available, call goes to Ujjwal. If Neha is available, Ujjwal wife. Call goes to Neha. So now both of them were able to handle the orders. Whatever order hundreds and 200s orders they are getting daily, they are able to now handle. They are happy. Everything is working fine. They are consistent. They are available. Everything is working fine for them. So what happened is one day, customer Ramesh calls to Ujjwal grocery store, to check his order status. And now this time calls routed to Ujjwal, and Ujjwal doesn't have entry for Ramesh's order. And Ujjwal was pretty shocked. At that time, Ujjwal thought Ramesh is telling lie. Suddenly, Ujjwal realized Ramesh might have placed order to Neha. And then he thought, what a big flaw is in his distributed system. His system is not consistent. He doesn't have updated data. So Ujjwal started thinking about how to fix this problem. And while thinking about it, Ujjwal got an idea how to fix this problem. So in the morning, Ujjwal asked his wife, Neha, whenever you get an order, yeah, whenever I will get a call for order, what we'll do is before hanging up that call, um, we will tell to each other about that order, and then we will update that order details to our notebook. So how the things will work is when customer one calls to Neha, Neha will note down that order details to his notebook, and Neha will tells Ujjwal also, I had customer one order in his notebook also. And after that, Neha will hang hang up the call. So this is the way now Ujjwal and Neha are able to handle the consistency problems. Whenever any one of them get a call for order, then they will note that order details in his notebook and inform his partner to update the that order details in his notebook also. And this is the way they solve the consistency problem. This system still has a flaw. Neha said to Ujjwal, "This system still has a flaw." Ujjwal was like surprised. Really? Yeah. Let's see where the system has a flaw. So Neha told Ujjwal, what if one of us doesn't report to work? That means we will not update those order detail to each other because one of us hasn't reported. For example, one day Neha got sick and she hasn't reported to work. So Neha will miss all those orders because she hasn't reported to work. So why designing a distributed system is not easy as he thought of. But Ujjwal is brilliant, right? So nothing is impossible for him. So he again come up with a brilliant idea. And the idea is Ujjwal says to his wife Neha, if any one of us will not report to work, and that day, at the end of the day, the person who reports to work will send an email to the other person, to the other partner with all the details of the order. And yeah, that's the brilliant idea. So I'll give you an example. So for example, on one day Neha hasn't reported to work and Ujjwal was at the work. So he got around 50 orders at that day. And at the end of the day, he lists down all those orders on that day and draft an email and send it to Neha. Next day, when Neha will come to work, first things he has to do is go through the mail and list down all the order in her notebook. Wow, that's a brilliant idea. Now they are consistent, right? Now their system is working perfectly fine. They are consistent, they are available. So, so it's fixed, right? No, my friend. So let's take another scenario. As of now, you got it right. So their online grocery store system is working perfectly fine. It's consistent and available. But what happened when one of them gets angry and stops talking to each other? So, for example, Neha got angry with Ujjwal and she stopped talking to Ujjwal. That means whatever order Neha gets from customer, so for example, customer 1 calls to Neha and place his order 1. But Neha is angry and she hasn't updated the detail to Ujjwal. That means they are partitioned, right? So now Neha and Ujjwal are partitions. They are not talking to each other. So when you keep operating successfully with this partition, then your system will be called partition tolerant, right? But if you see, when your system is partition tolerant, in that scenario, if you see over here, Neha and Ujjwal are available, right? So your whole infra you have set up, all the online grocery um, store they have set up, it's available. They are able to take the call, right? And Neha is angry. She is not talking to Ujjwal. They are partisan and they are continuing with this setup. They are partisan tolerant, but they are not consistent, right? Because Neha is not updating whatever order she is getting. If you see, she got order 1 and she hasn't updated that order to Ujjwal. So they are not consistent. If after some time customer 1 calls to Ujjwal to get his status of the order 1, he will not able to provide to customer 1, right? Because he doesn't know about customer 1 order. Neha hasn't updated it to Ujjwal. So you can see at this scenario, their whole online grocery setup is available and partition tolerant, but It's not consistent. It's not consistent, right? Now let's revisit CAP theorem theory again. I'm hoping you got all the idea right. What is availability, what is consistency, what is partition tolerant, and how a distributed system cannot have all of these three together. This is consistency, this is partition tolerant, this is availability. So what CAP theorem says is okay, as distributed systems cannot have all of these three. It can be either partition tolerant and available. So if you see in the above scenario where Neha stopped talking to usual, that means she is not communicating to usual, she is not updating the order, whatever she is getting from customer. So their system is partition tolerant and they are available because they are picking the call of the customer, but they are not consistent because usual doesn't have any latest order detail of any customer because Neha is not communicating that. So their system is not consistent. They are available and partition tolerant. Similarly, on the above we have talked about, right? Ki, your system either you can be consistent and available. When Neha was communicating to usual, she was updating the order details, whatever she was getting, they were consistent and available. And either they can be consistent and partition tolerant and they will not be available in that scenario when they close their online store. When they close their online store, that means they are not taking any calls, right? So they are consistent and they are partition tolerant, right? So they are not getting any calls, so they are not available. This is pretty much about CAP theorem. I try to explain it with very simple example. I'll create a new video with real distributed system examples, how CAP theorem is applied, getting applied to those real distributed system like MongoDB, DynamoDB, Cassandra. So I'll create a different video for those real distributed system examples. So I hope you got all the idea like what is consistency, what is partition tolerance, what is availability, and what is CAP theorem, right? Now I'm giving you one question, and I want you guys to reply in comment why distributed system cannot give up partition tolerant. You can put your answer in comment. I hope you'll like this video. If you liked it, subscribe to my channel. It will not cost you anything, but it will be helpful for me. Thank you. Bye bye.